Hey, fifth graders, how are you today? So we're going to start lesson 11. Sorry, I didn't put that title up there at the top, but this is lesson 11, and what we're going to be doing is some problem solving with line plots. And this is just part one of this lesson. Part two will come in a couple days, maybe a week. We can't do part two until we do more with fractions on line plots, but for today, we're just going to do some problem solving looking at some line plots. So here's my line plot. And this line plot is about the lengths of some fishing string in inches. So let's imagine like you're down at the creek or at a lake and you're fishing, okay? So what we're looking at is what is the length of the string that you're using. Now, this is not realistic because we wouldn't have fishing lines that are 15 inches long because that would be a really, really short fishing line. But anyway, this just for the sake of an example, okay? So when we look at this line plot, we can see that there's one fishing line that's 10 inches long. There's two fishing lines that are 11 inches long. There's three that are 13, two that are 14, and four that are 15 inches long. So we can read that line plot and figure that information out. And we can see that, 15 was the most common length of a fishing line. And we can see that 10 was the least common and 12 had nothing. So we can look at all of that and answer those simple questions. But today we're going to go into something a little bit more difficult than just looking at it and answering a question. So the first thing I want to talk about is something called the range. Okay. And as you get into middle school, you'll do more with this data analysis and talking about the range. But when you talk about the range, it's actually finding the difference meaning subtraction, between the highest and the lowest values. So when you're looking for your range of data, you're looking for the biggest or the highest number that actually has data and the smallest number that has data. So when we look up here at our line plot, doesn't matter. We're not looking at the x's to see which one has the most and which one has the fewest. We're looking at which fishing line was the biggest and which fishing line was the smallest. So we have four fishing lines that were 15 inches long. So 15 is our highest value, the biggest, longest fishing line, which then we have to look over to the left to find our smallest. Our smallest fishing line was 10 inches long. So to find the range of our data, it's the difference between the highest, also known as the biggest, and the lowest or the smallest. So when I look at this, my math problem then is 15 minus 10 because we're finding the difference. So our range of data, or the difference between the highest and the lowest, is 5. Okay, so when we look for the range or the difference, we're finding the biggest value that has an x above it and the smallest value that has an x above it. Okay, so our next problem solving question looks like this. Write an equation to determine how many total inches of fishing string there was. So we're looking for the total inches of fishing string. So this doesn't mean I can come up here and just count how many X's there are, because that's actually how many people had fishing string in this example, okay? We're looking for the total inches. So in order to find that, I have to literally add up the value for each one of these X's. So the value of this one right here is 10 inches. And I'm going to have to add that to the value of these two. So this one's 11 and this one's 11. So I have to do 10 plus 11 plus 11. And then I have to come over here and I have to add plus 13, plus 13, plus 13. So let's look and then keep going and then do plus 14, plus 14, plus 15, plus 15, plus 15, plus 15. Who wants to write out that long addition equation? So let's look at writing it a little simpler and then how we can solve it. Okay, so here's an example of our equation that could come from that. Okay, so we had one string that was 10 inches, plus there were two that were 11, plus three that were 13, plus two that were 14 inches, plus four that were 15. So we've used our parentheses and our order of operations in order to group this information. So now when I go down here and say, now I want to know how many inches of fishing string was there in all, now I have to solve this equation. I could, instead of using multiplication, you have a choice here. Instead of using multiplication, you can use addition, okay? So you could just, instead of doing 11 times 2, you could do 11 plus 11. You'll get the same answer. Instead of doing 13 times 3, you can do 13 plus 13 plus 13. I'm gonna go ahead and do this and show you how this would work. So you would end up with 10 plus 11 times 2, or 11 plus 11 is 22, plus 13 times 3, or 13 plus 13 plus 13 is 39. 2 14s is 28. 4 15s is 60. So now I have all of these numbers that I have to add up. So going over here to the side and adding that all up to get a grand total. 9 plus 8 is 17, plus 2 more is 19, and then 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we get a grand total of 159 inches of fishing line or fishing string. Okay, so when you're asked to find the range, it's the difference between the highest and lowest, and when you're asked to find the total amount, in your measurements, you have to add up everything. So let's look at another example of that. Okay, so here Bella's doing a science experiment which shows how many grams of salt were left after containers of various liquids evaporated, and the results are shown in the line plot. So over here we have a frequency table, and so it shows that 2 of the containers had 5 grams of salt left, 4 of them had 7 grams, 1 had 8 grams, and 1 had 10 grams of salt left. So I already did number 1, make a frequency table to show the data. So then my next question is, how many total grams of salt were left? It's not asking how many dishes of salt there were, it's asking how many total grams. So once again, we have to do one of those long equations to show this. So this equation would look like 5 times 2 plus nothing for 6. So we don't have to write 0 times 6, we just ignore it, okay? 7 times 4 plus 8 plus 10. So it looks like what's right down here underneath this green box. 5 times 2, 7 times 4, plus 8 plus 10. So when we solve this, we have 10 plus 28 plus 8 plus 10. So when I write that out and do that math, and calculators are okay for this because it's a lot of numbers. So 8 plus 8 is 16. 1 plus 1 plus 2 plus 1 is 5. So the final answer here, G, or the number of grams, is 56 grams of salt. And then we have our range question. It says, what is the difference between the greatest and the least value? So we have to look up here. Our greatest amount of grams of salt that were left behind was 10, and our least amount of grams of salt was 5. So to find the difference, we would do 10 minus 5. So our answer would be 5 grams. So the difference in our data from highest to lowest is 5 grams of salt. Okay, one last example here. Allie is cutting string pieces for her art project. The line plot shows the length of pieces Allie cut to use for her art project. Now, for the first time here, we're going to look at this with a few fractions in it, okay? Don't freak out, it'll be okay. So let's look at these fractions. Okay, so my first question is, how many total inches of string does Allie have for her art project? Well, since we're asking for the total inches, I'm going to have to add up all these x's. That's a lot of x's, guys. Okay, so first of all, we're going to want to write out an equation for that. So I already have that underneath the box, but I want you to sit here and think, what would my equation look like? I hope that you're sitting there thinking, oh, it would start with 12.5 times 2. Okay, so here's our equation. So 12.5 times 2 plus 13 times 7 plus 13.5 times 5 plus 14 times 5 plus 14.5 times 4. Okay, now this does get a little bit more complicated. If you remember how to multiply mixed numbers, that would work here. I think in this case though, because we have 12.5, 13.5, 14.5, those are kind of big numbers to do to change them into improper fractions. It's okay to do that. However, I would probably do some repeated addition here. Okay, so this is what it would look like. Okay, so if I were going to use multiplication to do this, I would have to change these into improper fractions, okay? So 12.5 would change to 2 times 12 is 24 plus 1 is 25. So you would have 25 halves times 2. So because it's a whole number, we have to put it over 1. So then looking at this, 25 times 2 is 50 divided by 2. But hey, we can do some cross canceling ahead of time and make this super simple. Okay, so these two have a common factor of 2. So 2 divided by 2 is 1. 2 divided by 2 is 1. So now it's 25 times 1 plus, over 1 times 1, which is 1. And we know that that equals 25. So 12.5 times 2 is 25. Now, if you don't want to use multiplication, and that's totally okay, and I'm going to do the rest of this using repeated addition, it would look like this. 12.5 plus 12.5, which half plus a half is 1. Okay, so we'd have 2 halves, which equals 1, and then 12 plus 12 is 24. So 24 and 1 together is 25. So there would be our final answer for that part. So we'd have 25 over here. Okay, so I'm going to continue to use addition here, and in a second you'll see all of my answers, because I'm going to pause and I'm going to do all the answers so you can see it, and then I'll walk you through it. Okay, so now all of a sudden you're seeing all of the answers over here at the right, well, showing all the work on the right and all the answers on the left. So my first answer was 25, and I walked you through that one. The second one is just 13 times 7, so I would use multiplication for that, and the answer is 91. The second one was 13.5 times 5, so if I'm using repeated addition, I'm just adding 13.5 5 times. So doing the fraction part first, half plus a half is 1, another half is 1.5, another half is 2, and then another half is 2.5, also known as 5 halves. Okay, but 2.5. So down here I wrote 2.5, and then adding up all of the whole number side, I have 65. And when I put 65 and 2.5 together, I end up with 67.5. The next one was 14 times 5, so I just did the multiplication. And the last one was 14.5 times 4, so I just did 14.5, added it together 4 times, so a half plus a half plus a half plus a half. Here's a whole right there. Cannot combine those together, that's 1. Combine those together, that's 2. So there's our fraction answer. And then 14 plus 14 plus 14 plus 14 is 56. Put that together and you end up with 58. So now over here at the left, I have all of my answers. And what I have to do now is add all of those together. So I have 25 plus 91 is 6, 9, 10, 116. And then add 67.5 to that, and I have a half, 13, 6, 7, 8, 183.5. Moving over here, so I have 183.5 plus 70, so a half, 3, 15, 253.5. Oh, this is getting pretty big. Okay, so 253.5, adding our final number of 58, we have a half. 8 plus 3 is 11. 5 plus 5 plus 1 is another 11. And then I have 2 plus 1 is 3. Okay, so up here underneath this blue box, I have the final answer. Let's hope I did my math correctly. So my final answer should be 311.5 inches of string. So let's check it out. Da, 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 da. Boom, yes. 311.5 inches of string. Now, I know that's a lot of math, but we are in 5th grade, and that is work that we should be able to do. Yes, it's going to take perseverance, and you got to push your way through that and just kind of double check your work the whole way through to make sure that you didn't make any mistakes so you get to that final answer. Okay, guys, so this was your intro into problem solving, finding the range and the totals. And you will have some practice on this coming up here very soon. Okay, so have a great day.